It rains diamonds on ice giants like Neptune and Uranus. And if you're anything like me, you heard that in your mind in its never-ending quest to question absolutely everything went, rain? How? Wait, what? Evaporation, condensation, precipitation, runoff. Diamonds? How? What? I had to make sense of it. So let's take a look at Neptune. Neptune's average temperature being negative 392 degrees Fahrenheit, it certainly does not get the ice giant name from being a distant relative of the Jotun. And though it's not one of the frost giants of Jotunheim, it does share a characteristic with Loki here in that it's a bit of a trickster. See, even though it's at the very end of the solar system and called an ice giant, the deeper you go into the planet, the hotter it becomes, with the core reaching temperatures similar to that of the sun. Interestingly enough, it's that very same heat that causes the water on this planet to become ice. Obviously not a type of ice we have on our planet, and certainly not one we would want. A unique state of water called superionic. A hot black ice is how they describe it. Now obviously this seems like an extremely foreign concept to a lot of us, and for good reason, considering the environment needed to create it is absolutely deadly. But with those high pressure and temperatures, they cause the oxygen ions to form into a crystalline lattice while the hydrogen atoms float around inside it, leading to a less dense black ice capable of conducting electricity. So we know there's plenty of water, but where does the diamond rain come from? Well, the idea came about in 1981 when Marvin Ross of the Lawrence Livermore National Laboratory published an article, "The Ice Layer in Uranus and Neptune Diamonds in the Sky?" and confirmed in 2017 with formation of diamonds in laser compressed hydrocarbons at planetary interior conditions. Now, according to the lead author of this paper and physicist at the Helmholtz-Dresden-Rossendorf Research Center in Germany, Dominic Krauss, it was one of the best moments of his scientific career. Not his last one, of course, because he published a sequel in 2020. And what did they say caused the diamond rain? Pressure, of course. Pressure on Neptune is about 100,000 times that of Earth's atmosphere. For reference, it took 400 times our atmosphere to implode the Titan submersible. Now, this immense pressure causes carbon and hydrogen atoms to compress together, forming the crystal, which then begin to slowly sink towards the core, or precipitate due to the sudden change in density. Then, like a snowfall worthy of the Kardashians, the diamonds accumulate new layers as they fall while touching other carbon atoms, allowing individual diamonds to reach sizes we can only dream about, and certainly large enough to carve a bed in which to dream of them.